Okay, so good afternoon everyone. Welcome you back to my YouTube channel. Presenting before you this wonderful lesson is the man Dan Berkeleyman. And of course, if you are new to this channel, consider subscribing, hitting the like button, and don't forget to share to others. And of course, if you want to register for personal lessons, you want to enroll for physics at HC Learning Academy, just inbox me on +260 777 66 40 46 on WhatsApp, and I'll be able to respond to you. So today we'll be solving this question, particularly both the question on top and the question below. So for the question on top, they were asking you to calculate the effective capacitance. So how do you calculate effective capacitance when you are given such a complex circuit? So the first thing that you're supposed to do, you can work out everything that is in parallel. So we'll start with this particular part. Let's start with these parallel capacitors. So since we have a 5 microfarad and 4 microfarad, the first thing that you can do is to work out that capacitors that are in parallel are just added. So we're going to have a 5 plus 4, which is going to give us a 9 microfarad. So here we're going to have 9 microfarad. Then we can work out this. So they are in parallel. So we're going to have 2 plus 3 plus 7. So collectively together, when you add them, you're going to have 12 microfarad. So collectively, all these together is 12 microfarad. Okay. So we're going to have something like this. Another circuit which is going to be like that. So we can have our 9 microfarad here. We can have our 3 here. Just a rough drawing. Then here we are going to have another capacitor which is going to be 12 microfarad. And of course here we are going to have our 6 microfarad, like that. I want you to notice that this guy and this guy are in series. So we can work out everything in series. We can start with the ones on top. So we can start with our 9 capacitors that are in series. You just have to multiply them and eventually add them. So this is going to be 9 multiplied by 3. This is going to be like 27 over 12. So divide by 12. This is going to be like 2.25. So that's the capacitor which we are going to have on top. It's going to be 2.25. Then we can work out underneath. We see. So the capacitor underneath is going to be 6 multiplied by 12 all over by, it's going to be 6 plus 12. 6 multiplied by 12, okay, 72. Then 6 plus 12, 18. 72 divided by 18. We are going to have a 4. So we're going to have a 4 here. Now these are in parallel. So our equivalent capacitors, capacitor is going to be, so we can say capacitor equivalent you can, since they are now in parallel, so you can just add them. 2.25 plus 4 which is just going to be 6.25 microfarad. Basically, that is just how you solve this particular question. That's how you solve this particular question. Okay, not really complicated. It's just how you simplify everything. Okay, now we can proceed. Let's try question 4. Question 4, they are saying 4 capacitors are connected as shown below, where C1 is equal to 15 microfarad, C2 3 microfarad, then C3 6 microfarad, and C4 20 microfarad. Find the equivalent capacitance between points A and B. So they want us to find the equivalent capacitance between this point. Let me just use a red pen. Between this point, which is A, and this point, which is B. So first of all, we can work out whatever is in series. This is in series. So when we work out that, we are going to have a single capacitor here. So let's try to work them out. What is our C1? C1 is 15. So 15 multiplied by C2, which is 3. Then all over by 15 plus 3. Okay, let's see what we're going to have. So 15 multiplied by 3 divided by 18. Notice that we are getting a 2.5 microfarad for the 2. So this is 2.5 microfarad. So it's going to be in parallel with C3. What is C3? C3 is 6 microfarad. So we can try to add. So when we add them, we are going to have a single capacitor, which is going to be here. So let's try to add them. This is going to be 2.5 plus 6, which is going to be like 8.5 microfarad. So we're going to have 8.5 here. Now remember, we also have C4. C4 is 20 microfarad. So you add them in series. So this is going to be 8.5 multiplied by 20 over 8.5 plus 20. So this is going to be 8.5 multiplied by 20 divided by 8.5 plus 20. Notice that the equivalent capacitor is equal to 5.9 microfarad, of which your equivalent capacitor, you write it in its standard form and units, is going to be 5.9 multiplied by 10 to the power negative 6 farads. Okay, this is your total. This is your total. Now the question is saying, okay, this is A. B is saying, we calculate the charge on each capacitor if a 15 volts battery is connected across points A and B. Now, this is something really very interesting. Now, look at this HC. So, if you are not part of HC Learning Academy, ensure that you register. You have access to all the lessons that I was teaching on capacitors, or buy the lessons on capacitors. You'll be able to see how we are able to calculate everything. I want you to see that if you were to put a battery between A and B, okay, let's say we can put a battery here, okay, (15 volts), you'll be able to know that for capacitors that are in series, they will have the same charge. Capacitors that are in parallel will have the same voltage. So in parallel, same voltage; in series, same charge. Now, if you are part of HC, I'm sure you remember I always encourage students to find the equivalent capacitance. Whenever you are dealing with capacitors question, find your equivalent capacitors, find your total charge. So in this case, we can calculate our total charge. So you know that capacitance is equal to charge over voltage. So let's calculate the total charge. So what is our capacitance? It was 5.9 multiplied by 10 to the power negative 6. Then what is our voltage? It's 15. Oh, by the way, we're supposed to be dividing, not multiplying. Okay. Well, we're multiplying, thank you. So supposed to multiply as usual, as you can see from the formula. So multiplying the capacitance, which is C, multiplied by the voltage. So our voltage is 15. Our total charge is going to be 5.9 multiplied by 10 to the power negative 6 multiplying by 15. So this is going to give us 1, 2, 3, 4, 5, 8.85 multiplied by 10 to the power okay, this is going to be 8.85 multiplied by 10 to the power, let me see, 1, 2, 3, 4, 5 to the power negative 5. Okay, so this is going to be coulombs. Okay, so basically this is what we have. Now we can calculate we've calculated our total charge. So now the next thing that we're supposed to do is this. Look at this. When you put the battery, okay, between A and B, you understand that the charge which is passing at this particular point, the charge which is passing, which is coming from this battery, remember this charge we have calculated is for the entire system, meaning as it keeps on flowing in this direction, as it keeps on flowing in this direction, when it reaches this capacitor, it will be the same charge, right? Because it is in series with the battery. So the charge which is going to be at C4 is 8.85 multiplied by 10 to the power negative 5. But the voltage in series is going to be different. So now they want us to calculate the charge also here, the charge here, the charge here. We need to know the amount of voltage which is reaching these guys, because as the voltage is coming like that, when it reaches here, you know what happens? Including the charge, it is going to move like that. The charge is going to reduce, or it is going to separate so that it can reach both capacitors. So it will move like that. So the next thing to do, you are supposed to find first of all the voltage which is at capacitor 4. So we know that capacitor is equal to charge over the voltage. Okay, let's find that C4. So a cross multiply, our voltage is going to be, the charge is the same, reaching C4. So you can say 8.85 multiplied by 10 to the power negative 5 all over by, then what is the capacitor at C4? C4 is 20 multiplied by 10 to the power negative 6. So 8.85 multiplied, supposed to be 5, multiplied by 10 to the power negative 5. We are dividing it by 20 multiplied by 10 to the power negative 6. Then you are going to have the voltage which is equal to 4.4 volts. So 4.4 volts is the voltage which is at the C4. Now, as it keeps on going this side, it will start separating. It will demarcate. Some will go this side. Some of the charge will also go this side. So what do? You need to subtract whatever you have calculated for that capacitor in series from the 15. So I'm going to say 15 minus 4.4. So 15 minus 4.4, which is going to give us 10.6 volts. So this implies that 10.6 volts is the one which is now being dispersed in these capacitors that are in parallel. So you have 10.4 volts here. At this point, it's the same. Now, you want to calculate the charge at C1 and C2 capacitors. But I want you to remember that C1 and C2 are in series. And because they are in series, when you calculate your capacitor for C1 and C2, you are finding this. Okay? So it is 2.5. And because they are in series, they will have the same charge. That's what I said. So you will just use this same guy there. So you're going to say the charge at both capacitor 1 and 2 is going to equal to the same capacitance which you calculated, which was 2.5 multiplied by 10 to the power negative 6. So you can just go directly multiplied by what is the voltage reaching? It is 10.5. So 10.6. 2.5 multiplied by 10 to the power 6 negative 6 multiplied by 10.6. 1, 2, 3, 4, 5. So you're going to get 2.6. 5 multiplied by 10 to the power negative 5 coulombs. So this is the voltage which is reaching this capacitor here and that capacitor there. Okay? That's the charge rather. The charge. That's the charge reaching that capacitor and the other one. That's how you calculate the charge for capacitors in such a question or in such a scenario. Okay? They're very simple. But I want you to notice something. This capacitor is very much different from the rest. Okay? This capacitor here, sorry, let me just grab the board. So this capacitor and this capacitor having this particular charge because they are in series. But this one is in parallel to the two on top. So it will have its own charge. How do you calculate? It's the same thing. So our charge for Q3 is going to equal to what is the capacitor? Capacitor at Q3, it's 6. So 6.0 multiplied by 10 to the power negative 6. And then what is the charge? Of course, the same, 10.6. So 6.0 multiplied by 10 to the power negative 6 multiplied by 10.6. 1, 2, 3, 4, 5. This is like 6.36 multiplied by 10 to the power negative 5 coulombs. Basically, this is how you calculate all the charges for this particular question. If you found this video interesting and helpful, consider subscribing, hitting the like button, and don't forget to register for personal lessons even as you prepare for anything. Thank you so much.